Okay, so that's our answer. So then to check your answer to see if you got it right on the test, we can learn what we learned yesterday. If they truly are inverses of each other, then when we plug them into each other, we should get x. Okay, so at least take you through this once. The inverse goes into f. So this expression right here, I'm going to throw in right here. Okay, so that would equal 2 times x, and then I got to plug in 5/2 x minus 3 plus 6 all over 5. Okay. All right, so when we distribute 2 and do the multiplication, that gives me, well, this 2 over 1 cross reduces, so that's gone. Gives me 5x, 2 times 3 is 6, and then I still have the plus 6. These 6's can now be combined to get 5x over 5, and 5 divided by 5 is 1. So I get x. Okay, I'll pause for a moment. You try the check the other way. You do this one. Try the original function plugged into the inverse and see if you get x. And then move on to the next one. All right, so here we go. Multiply straight across. Gives me this. 10x divided by 10 is 1x. 30 divided by 10 is 3. And so you see how we get x. So confident that we did it right now. Okay, I'll say one more time. That's an optional step. You got to make sure you can at least get your new inverse, okay, by doing the other stuff. Okay, let's look at number 11. Step 1, use the horizontal line test. 2x to the 6th power. When I graph that, I get a graph that hopefully is very clear to you now. It has repeated y values. This is not 1 to 1. So this is not 1 to 1 from just viewing the graph, right, from the HLT. So if it's not 1 to 1, it doesn't have an inverse function. It doesn't have an inverse function, we're done with the problem. I can't go find an inverse function if it doesn't have it. So no inverse function is the answer. If you have a multiple choice like this one, that'll be one of your options. No inverse function. Okay. Let's take a look at 12, and then you'll try 13, then we'll wrap it up with 15. This one can be a little bit tricky on the horizontal line test, so pay close attention on this one. Now this is just a parabola or quadratic function that has a horizontal shift, shifted to the left 6 units. Good things to talk about and review as we're heading into a test that reviews those transformations. Now when you have a restricted domain, here's your options. I can just go to the graph and restrict the domain on my own. X has to be greater than or equal to -6. So -6 starts right there. So basically the graph we're going to view is from there that way. And that is 1 to 1. That will pass the horizontal line test. If you want your calculator to chop that off, let me show you how you can do this. I have to go back to my y equals, and at the very end, here's what I do. I just put my domain in parentheses. So I just do another set of parentheses. I do x, and then the greater than or equal to sign is under test, right here. It's right below alpha. So if I hit second test, I can choose the inequality greater than or equal to -6. Close it. Okay, so that's what that would look like. And I can go ahead and graph, and it chops that parabola in half for me. Okay, it's not needed. If that confuses you, just realize that you could have done what I did with this piece of paper and chopped it off the same way. Okay, so this does pass the horizontal line test. Yes, this is 1 to 1. Okay. So on to step 2. Let's interchange x and y and get this thing rolling. Step 2 simply says change f of x with y. So if you wanted to do this and jump to step 3, fine. You don't even have to number these as you go. I don't care, right? So step 3, interchange x and y now. So x equals y plus 6 quantity squared. Basically, the range gets restricted now too. I could say y is greater than or equal to -6, but you don't have to write it down. All right, so now we got to solve for y. So y is inside this quantity squared. It'd be very helpful to get rid of that exponent. You don't want to expand this. It's going to make it tougher for you to solve for y. So let's take the square root of both sides. So either handwrite it in here if you don't want the brackets around it, square root each side, or square root each side. Go ahead and show that. Square root the x. So now I have the square root of x equals y plus 6. Okay, now the last step is just to subtract 6. So here's our inverse. Well, here, I'll just write like this first. Square root of x. The minus 6 should not be under the radical, right? I didn't take the square root of that. The 6 was over here by itself. So make sure the minus 6 is outside of the radical. Okay, the fourth and final step is just to use inverse notation. So the inverse function is the square root of x minus 6. That's it. Step 5, check it if you want to. All right, you guys try 13. Go through that 4-step process. If you're waiting for me, don't do 14. We're going to skip that one anyways and end with 15 in just a moment. Do that one together. Okay, try 13. Okay, here's your feedback for this. It definitely will pass the horizontal line test. It's a square root function. So interchange x and y gives me this. And then we're kind of stuck. Can't do anything with y until this radical's gone. So we'd square both sides. So square the x, square that radical to let it disappear. Now move the 3 over to get x squared minus 3. And then we divide by the 2 to get this. Okay, or maybe even wrote it as, if you divide them both by 2, maybe you have 1/2 x squared, or x squared over 2, minus 3/2. That's all right too, okay? All right, skip 14 and wrap it up here at 15. 15 kind of brings a lot of concepts together. So find the inverse of this function with a restricted domain. And then graph f and the inverse on the same graph. This is the domain range of f in the inverse. I'm going to start with the graph, and I think you should too, and then we'll go back to finding the inverse. All right, so to graph f, it's a real simple quadratic shifted up 1 unit, but it's restricted. So why don't we just use a table? Sure, you could use your graphing calculator to help you get these values, but this is pretty easy math to do. So let's plug in values that are greater than or equal to 0. So 0, 1, and 2 will work. Or you can make up a couple more if you want to. So 0 squared plus 1 gives us 1. 1 squared plus 1 gives us 2. And 2 squared plus 1 gives us 5. Kind of like those piecewise graphs. Sometimes they gave us quadratics that were split like this. So this is not a new skill. So here's the parabola. Shift it up 1 unit, and it's only half because of that domain. Okay. All right, here's what I want to start with the graph, because in the first example we did yesterday, the inverse order pairs are so easy to find now, aren't they? Flip-flop. So if this is 0, 1, 1, 0 must be on the inverse. 2, 1 must be on the inverse, and so must 5, 2. So if I plot those, we get this square root looking graph. Okay. And remember, we can also check, does it look like it's symmetric to that diagonal line? Y equals x, looks pretty good. Yep, it does look like it's going to be symmetric to that line. Okay, so we got that part done. go back to finding the inverse. Okay, so to find the inverse, another reason why I want to start the graphs is because what we just did up here. We always check the horizontal line test first, right? So the HLT does pass. So we can move forward on step 2. Okay, so to find the inverse, I'm just going to move it on right down here. Let's interchange x and y right now. This is y right here, then I'm going to interchange it. So x equals y squared plus 1. Also, x greater than or equal to 0, well then y is also going to be greater than or equal to 0. Now that changes too. That will help in the final step, so we should write that down. Okay, really just 2 steps here. To get y by itself, let's subtract the 1. And then we take the square root. And when we take the square root, we're supposed to always do plus or minus. Right now I have y equals plus or minus the square root of x minus 1. Okay, but this is going to tell me which one I should use, the plus or minus. Y has to be positive. So we're going to use the positive version. If it said less than or equal to 0, I'd use the negative. So here's my inverse function. The inverse is positive square root of x minus 1. Okay. The negative, if I had a negative out front, remember reflections from before? The negative would be down here. This is not the negative. That's the positive version. Okay. All right, and last step. Let's get the domain and range and wrap this up. So the function f, the domain was actually given as x is greater than or equal to 0. Kind of hard to mess that up now, but here's our graph. If you want to see it, 0 to infinity with a range of, let's just shift it up 1, from 1 to infinity. And then the inverse, these should be switched, but might want to peek at your graph to check to make sure it's matching up. It clearly does start at 1, including 1. And then the range is 0 to infinity. Okay. All right, so today's assignment is pretty important. It kind of wraps up all of that, everything we've done in 1.9. So work hard at it so we can focus on reviewing on some of the other sections. Okay.